Here we will talk about the nuclear stability. We have two types of elements, the stable element and unstable element. The stable element, they don't tend to decay their nucleons, but unstable element tend to decay their nucleons. Tend to decay their nucleus. Here we have a diagram that study the nuclear stability. The ratio between the number of neutrons and the number of protons detect if this element is a stable element or unstable element. Stable nucleus or unstable nucleus. Here in this diagram, the relation between the number of neutrons and the number of protons. The ratio between number of neutrons and number of protons detect the stability of the element. In red line, this is called the line of stability. Neutrons equal to the protons. And in yellow line, this is called the belt of stability. Belt of stability. And any elements lies on the belt of stability, so this is stable element. This is stable element. But any element lies on the right side of the belt of stability or left side of the belt of stability or above the belt of stability, these are unstable element. So here the belt of stability deviates slightly for left side above the red line. Any element lies on right side or left side or above the belt of stability, so these elements are unstable element. For example, here in this diagram we can see element A, which is located on the right side of the belt of stability, and this is considered as unstable element. Also C, which is located on the left side of the belt of stability, this is considered as unstable element. And B, which is located above the belt of stability, also this is considered as unstable element. Let's see why these elements are unstable and how can they tend to be stable. Pay attention. The elements that at the left side of the belt of stability, such as C614, carbon 614, pay attention. On the left side, the elements are not stable, unstable elements. Why? Because they have the number of neutrons is larger than the stability level. They have a large number of neutrons, so the ratio between neutrons and protons, N and Z, is larger than the stability ratio. How can these elements reach to stability? By emitting beta particles, which is called negative nucleus electron. Why they emit beta particles? to transfer one extra neutrons, as they have a large number of neutrons, transfer it to protons. Then the ratio between N and Z, the ratio between neutrons and protons, approaching to the belt of stability. So by this way they tend to be stable. They approach to be the belt of stability, then they approach to be stable. Okay? Here the element at the right side of the belt of stability, such as potassium 1935. These are unstable elements on the right side of the belt of stability because they have the number of protons larger than the stability level. Number of protons here larger than the stability level. So the ratio between neutrons and protons, N and Z, is small. To reach to the stability, to approach to the stability belt, they must emit a positron. Positron, this is the type of radiation to transfer one extra proton to neutrons, one extra proton to neutrons, as they have a large number of protons, and the ratio between neutrons and protons here approach to the belt of stability. Let's see what happens to the elements above the stability belt. The elements above the stability belt, they are unstable because they have the number of nucleons. What's meant by nucleons? Number of protons and neutrons together. The particles inside the nucleus is called nucleons, is larger than the stability level. To reach to their stability, they must emit alpha particle from the atom nucleus. Okay? 2 laws, 2 protons and 2 neutrons to approach the belt of stability. And by this way, the elements tend to be stable by 3 ways. If the elements on the right side, so they tend to be stable by emitting positron. If the element on the left side, they tend to be stable by emitting beta ray. If the element above the belt of stability, so they tend to be stable by emitting alpha ray. Okay?